The last human being to set foot on the moon was the commander of Apollo 17, Gene Cernan. That was December 1972.
Wow.
As he took the last step from the lunar surface, he said, "We leave the moon as we came, and hopefully as we return, with peace and hope for all mankind." As we were talking about earlier, we are entering an age that had been relegated to science fiction, but it is no longer science fiction. We will be returning to the lunar surface, and this time it will be to stay. It will be to learn what we need to do to start moving further out into the solar system, sending humans to Mars. And we're going to talk a little bit about that here today. The best way to learn about today and the future is to learn from the past, particularly from the mistakes that we've made, so we don't repeat those. NASA was formed in 1958, the National Aeronautics and Space Act. And literally, Congress declared that everything NASA does is for the benefit of all. The expansion of human knowledge, improvement of air and space vehicles, benefits to be gained from what we do right down here on Earth, and we're going to be talking about those. Keeping us as a lead in science and technology, and at fostering cooperation with other nations around the world, and making sure that we are using the resources of this country in science and engineering in a most effective manner. We are doing exploration, as humans have always done exploration. But sometimes the reasons for this exploration are not as necessarily lofty and complex as you might think. Why did Europeans start exploring this planet in the 15th century? Well, mainly because they hated their food. Obviously, there was no refrigeration. Meats had to either be drowned in salt to preserve it or to keep it from spoiling. So they used a lot of spices like pepper to cover up the taste of the salted meat or to cover up the fact that they were eating spoiled meat. Well, those spices came from what was called the Indies, China, Japan, the Asian continent. They had to be brought across thousands of miles through mountains, through deserts, and there were dangers from enemy nations attacking them, from bandits taking their spices. So they had to find alternative ways. But that was dangerous too, because the oceans were unknown. It was thought at one time that there was only one ocean on this planet. We didn't know much about the world until we started exploring. That's why most people thought the world is flat. Well, the evidence of our eyes when you look outside is, duh, the world is flat, isn't it? Well, no, it's not. The problem was, they had really no idea of how large the world was at the time. But the reasons for exploring space today are a little bit similar, a little bit different. We're doing that same type of exploration. We're pushing the new frontier, except this time the new frontier is off this planet. When we explore the solar system, we're learning more about our place in the universe. We're learning more about us. Every planet in the solar system formed from the same materials. So whether we go to the moon or to Mars, we should find the exact same types of rocks that we find here. We should find the same types of minerals. We should find the same types of water compounds. They may be in different proportions. They may be in different quantities. But we should find the same things throughout the solar system. As we learn more about these planets, we're also learning more about this planet, and particularly Mars. We'll talk about that in a little bit as we go on here. In moving outward as we do, it is an impetus for new science and new technology and new engineering applications. Things that we take advantage of today that we don't even think about. We're going to talk about that in a little bit as well, too. It's an opportunity for us to work together. I believe that the leader of every nation on this planet should be required to fly in space, because those lines we see on maps and on our globes don't exist. They are human contrivances. We are ill-mannered children that were playing in the sandbox in a playground. It's just now that sandbox has gotten way too big. Going from the Earth out into the solar system, out to Mars, for instance, is like crossing stepping stones, going across a river to get to the other side. We started with Project Mercury, which was the first attempt of the United States to put humans into space. We didn't know if human beings could even function in space. We didn't know if a human being could swallow in space, or eat, or even breathe in space. That's why the Mercury program launched on intermediate range ballistic missiles, a very small spacecraft. An astronaut did not get into the Mercury spacecraft. They put it on. An astronaut could not be taller than 6 feet to fly in Mercury because they literally could not get in the spacecraft. From Mercury, we went to Gemini, a larger version of Mercury with the service module carrying a crew of 2. That set the groundwork for what Apollo would do to take us to the moon. It showed we could use a propulsion system to change orbits, that we could do spacewalks, that we could do rendezvous and docking in space, that everything that we needed to do in Apollo that had to work on Apollo had to be tested. That's what Gemini did. Then, of course, the Apollo program. 12 lunar missions. Following those lunar missions, we did the Skylab Orbital Workshop, our first space station, which was actually built inside the 3rd stage of a Saturn V. We did the Apollo-Soyuz test project with the Soviet Union. It was the first time that the United States and the Soviets ever cooperated on a space mission. That laid the groundwork for what we enjoy today on the International Space Station, which has had a continuous human presence in space now for the last 22 years. And of course, 30 years of the Space Shuttle program, which was not without its tragedies, unfortunately due mainly to stupid human decisions. The Space Shuttle program was brought to an end in 2011 after successfully assembling the International Space Station in orbit. The space station has modules from the United States, from Russia, from Japan, from the Europeans, astronauts from all of those countries, and Canadian astronauts, Korean astronauts, Saudi astronauts. The space station is the size of Brown Stadium in Cleveland and weighs almost 1 million pounds in Earth orbit. It orbits the Earth about the same distance of Cleveland to Cincinnati. So it's not that high up, which is why you can see it when it passes overhead at night and the sun is reflecting off that structure. But as I said, we've had a continuous human presence on the space station now for 22 years. It's teaching us that we can assemble a very large spacecraft in Earth orbit, and that's what we're going to need to send humans to Mars. Astronauts can survive in the microgravity environment of space for years. That's what we're going to need to go to Mars. It's our first test bed that lets us know that we can start sending humans further out into the solar system. As I'm going through this, if anyone has any questions, please feel free to raise your hand. I'll also leave some time at the end for questions as well. Yes, sir?
Just a question about the Mercury symbol. What is that from?
That is the astronomical symbol for the planet Mercury with the 7 in it.
7 astronauts?
For the 7 of Mercury astronauts, yes.
Thanks.
We're now in the area of commercial crew and commercial cargo, where the contractors that we always worked with to build our spacecraft and to maintain them and to operate them, now we're saying, we're not going to look over your shoulders like we did before. You have the smarts. We're going to tell you what we need. You build it. We'll do some final checks and we'll use it. So it's making it more of a commercial, like getting on a commercial airliner, like getting on a commercial cruise ship. That's involving SpaceX, Northrop Grumman. Will soon involve Sierra Space and United Launch Alliance as well. NASA's venture after the space shuttle is the Orion spacecraft, which is essentially a larger version of Apollo. We're designed to carry between 4 and 7 crew members into space. It will be used to send humans to the International Space Station, to the moon, and eventually onto Mars. And that will be under the Artemis program. Artemis consists of the Orion spacecraft, the Space Launch System, commercial lunar landers for science and exploration, as well as eventual human landers. And that we'll be talking a lot about that here shortly. And all of this is to get us across that river to the other bank. And that other bank is the planet Mars. The Apollo missions, 12 crewed Apollo missions went to the moon. 12 crewed missions total. 9 went to the moon. 27 astronauts went to the moon. Of those, 6 landed. So 12 human beings have walked on the lunar surface in the history of our space exploration. Unfortunately, the Apollo program began with a tragedy. On January 27th, 1967, the crew of Apollo 1 was lost during a ground test of their Block 1 Apollo spacecraft. There was a short, an electrical short, which sparked a fire in the pure oxygen environment in the spacecraft. That fire, as you can imagine, spread very quickly. There were toxic fumes released. The pressure in the capsule built to actually the capsule ruptured and extinguished the fire. But enough toxic fumes were released that the crew died of asphyxiation. After that, the spacecraft was completely redesigned and flew successfully on the Apollo 7 mission in 1968. Commander of that was Wally Schirra, one of the original Mercury astronauts. Don Isley was a crew member. Don Isley was originally from Columbus, Ohio. Then we got very audacious. Apollo 8, in just December of 1968, sent the first human beings to leave this planet when Apollo 8 orbited the moon over Christmas in 1968. Frank Borman, Jim Lovell, and Bill Anders. Jim Lovell was a Cleveland native. Apollo 9 was a low Earth orbit test of the lunar module, just to make sure it functioned the way it was supposed to get astronauts to the moon. Apollo 10 was a dress rehearsal for Apollo 11. They went to the moon. They came within 50,000 feet of the lunar surface of landing. They could not land. They did not have EVA suits. They did not have the oxygen to land. They did not have the consumables to land. But they came within 50,000 feet of the lunar surface. That said, we were ready. So the next mission, Apollo 11, in July of 1969, saw Neil Armstrong, Edwin Aldrin, and Mike Collins to the lunar surface. Armstrong, of course, and Aldrin landing. The picture you see on the right here is taken from a spacecraft that has been in lunar orbit since 2009. It's called the Lunar Reconnaissance Orbiter. Its purpose is to take high-resolution photographs of the moon, do soundings and research looking at the topography of the lunar surface, to look at where mineral deposits are, where water might be in the permanently shadowed craters in the polar areas of the moon, and also to scope landing sites for the future missions. You can see in this picture the Apollo 11 lunar module descent stage, still on the lunar surface. And you can see where a lot of the hardware that was left on the lunar surface is there. The footprints of the Apollo crews are still visible in the lunar regolith. Apollo 12 followed in November of '69, landed within 600 feet of the Surveyor 3 spacecraft, which had landed there about 3 years previously. Actually brought back some pieces of that spacecraft. Apollo 13 was supposed to be the third landing on the moon. About 200,000 miles from the Earth, a problem developed with one of the liquid oxygen tanks. It had an electrical short. The tank exploded, took out the main power system for the command module. The crew had to use the lunar module as a lifeboat to survive, to get back home. But they did make it back very successfely.
Did you ever find out what caused those shorts?
Yes, there's a very detailed report that you could download. It was a high voltage piece of hardware that powered a heater in the tank. It was the incorrect voltage compared to what was applied to it. It wasn't. It was an older model, and it missed being caught. There was also some damage to the wiring because it turns out the tank had been dropped prior to installation in the service module. Apollo 14 was commanded by Alan Shepard, again, one of the original 7 Mercury astronauts. Did extensive research. They carried with them what was euphemistically referred to as a golf cart to carry all of their tools and items as they went around the lunar surface. Apollo 15 did a little bit better. They carried the first lunar roving vehicle, a electric-powered car that allowed them to go even further from the landing sites. Apollo 16, again, in different areas of the moon, but again, you can see the descent stage of the lunar module, and here you can actually see the shadow of the flag that was planted on the moon by the crew. I love this picture on the left. That's John Young, who was the commander of the mission. It's hard to tell from this, but he was actually jumping. He's probably about 6 feet off the lunar surface saluting when this picture was taken. It kind of looks like he's standing on a little hill there, but no, he's about 6 feet off the ground.
Is he saluting?
That's what's one advantage of 1/6G, you know? We would all weigh 1/6 of what we weigh here if we go to the moon. I'm signing up. I don't know about anybody else. And this is Apollo 17. They spent 3 days on the lunar surface. You can still see, again, the hardware they left there, the tracks left by the lunar roving vehicle on the lunar surface. Now, if you notice in all these charts I've shown you about Apollo, I had names highlighted in yellow. These are the astronauts who walked on the moon. Only 4 of them are still with us. They are all over 90 years old. I count myself fortunate. I think I'm the last generation that remembers watching Neil Armstrong walk on the lunar surface. I was 7 years old when that happened. But what they did over 50 years ago, we're going to start doing in the Artemis program. Artemis is the perfect name for the program because Artemis was the twin sister of Apollo. She was the goddess of the moon in Greek mythology. When we send astronauts back to the lunar surface, they will literally be going where no human has gone before because we will be going to the south polar regions of the moon. The reason for that is there are craters in that area that have never seen sunlight. And we have indications that the asteroid fragments and cometary fragments that formed those craters, of course, brought water with them. And that water is frozen into those permanently shadowed areas. Of course, water will be the most precious resource we can find on the moon or Mars because we need water to survive as human beings. We can separate water into oxygen and hydrogen. That creates electricity. We need oxygen to survive, and hydrogen and oxygen just happen to make the most efficient rocket propellants. So just as settlers did from the eastern seaboard of the United States and moving west, living off the land, that's what we'll be doing on both the moon and Mars.
Will there be communication with the South Pole? Is it out of the dark side of the moon?
No,
Oh, okay.
no. And actually, when you really get down to it, there is no such thing as a dark side of the moon.
Okay.
The moon is gravitationally locked with one side facing the Earth. But that far side gets as much light as the side we see. A day on the moon is 2 weeks, 2 Earth weeks. A night on the moon is 2 Earth weeks. If you're on the equatorial regions of the moon during the day, it's about 250 degrees Fahrenheit. At night, it's about 300 degrees below 0 Fahrenheit. Most spacecraft can't survive that cold for that long amount of time. That's going to be tough. In the southern polar areas, there are regions that are in essentially a permanent twilight. So they are always illuminated at a very low level. But then right next door are areas that never see sunlight. And you have craters that are so deep that light has never penetrated them. So they have the coldest temperatures in the solar system. Literally a few degrees above what's known as absolute zero. Absolute zero is where all atomic motion ceases. They are literally the coldest places in the solar system.
Is there no spot on the moon anywhere that doesn't have those extreme temperatures and extreme heat?
No.
Extreme cold?
No, because the moon doesn't have an atmosphere. We have a thick atmosphere. So we heat from convection as much as we do radiation. The atmosphere is mixing those temperatures together. Mars, the Martian atmosphere, for instance, is only about 1% the density of Earth's. It's mostly carbon dioxide. And Mars has seasons just like the Earth. So if you stood on the Martian equator at summer, your feet could be 80 degrees Fahrenheit. The top of your head would be 50 degrees below zero. Because there's no convection. There's no convection.
Lay flat.
Yeah, so bring suntan lotion and a parka at the same time.
Feet tan.
So from where we've been to where we're going, you know, we've had a constant presence in low Earth orbit of humans for the last 22 years. We're helped strengthening those partnerships with nations across the world on ISS. Now we're going to turn that into a low Earth orbit economy. There are companies that are looking at producing products on the space station. We're looking at commercial space stations to succeed the International Space Station. So we'll be manufacturing products in that microgravity environment that we cannot make on Earth because gravity will not allow the constituent components to mix. But we can do that in space. We've been mapping the moon in detail with the Lunar Reconnaissance Orbiter since 2009. And we're learning to do those communications between Earth and the moon on a routine basis. And that will be extended to a way station called Gateway, which will be talking about that. We'll be setting up GPS networks around the moon. We'll be setting up essentially cell phone towers on the lunar surface. But it won't be NASA doing it. It'll be commercial companies. We'll be buying their services. There will come a day when you can look at the moon and you will see the McDonald's golden arches. I dread that myself, but it will happen. It will happen.
It's like 2001.
Yeah, yeah. I don't know about Howard Johnson's anymore, though, but you know. Phase one, you know, we did an uncrewed test of the Artemis 1, the Orion spacecraft, the Artemis 1 mission around the moon in 2022. That spacecraft is going through its final testing to certify it to carry humans on the Artemis 2 mission, which will send a crew around the moon. We're starting to send small landers to the surface in the Commercial Lunar Payload System program, or CLPS landers, and this will continue to build on. We will start building the way station called Gateway in a very special location around the moon. So this will be phase one, and this will probably carry us through the early 2030s at least. But this is a combination of NASA, commercial partners, doing things. Like I said, commercial partners. You know, commercial satellites are communication satellites orbit the Earth. Whether it's cell phone, satellite phones, television, etc. We can do the same thing at the moon. We can have commercial people do that. So that's what we're doing right now. We're looking at different power systems because typically we rely on solar power systems. You're not going to do that too much at the South Polar region. So NASA is revisiting something it has not done since 1965, and that is nuclear fission power systems. The fission surface power system. The first demonstration of this will be at the lunar South Pole to provide 40 kilowatts of power to the astronauts. And this will be extended to the surface of Mars for systems providing hundreds of kilowatts of power. The fission surface program is led at the Glenn Research Center here in Cleveland. Phase two, we will complete the Gateway station, start sending human landers there. They will be refueled at Gateway. Orion will carry crew to Gateway. They will board the landers to go down to the lunar surface, come back to Gateway to get back in the Orion to come home. We'll start building small structures on the lunar surface, the Artemis Base Camp, and start growing those as time goes on. All of this will tell us what we need to do this successfully on Mars. You know, getting to the moon and back is days. Getting to Mars and back is years. So you want to make sure you have as much bugs wrinkled out of the system before you start sending humans to Mars as you possibly can. We've contracted with a large number of companies for the commercial lunar payload suppliers that The first launch of United Launch Alliance's Vulcan Centaur launch vehicle was a short time ago. It took the Astrobotic lunar lander, which was built in Pittsburgh. You can go down to their factory in Pittsburgh and look through the window and actually watch them building these landers. Unfortunately, they had a problem with a valve, a very simple valve on a helium tank that's used to pressurize their thrusters. It stuck open, and the tanks got overpressured and burst. So that mission was lost. On Valentine's Day, SpaceX launched another company's lander, a company called Intuitive Machines. Their Nova C lander, their first one, which they named Odysseus. It's due to land next Wednesday.
Oh.
So we'll see how well they fare. But all of these companies will be providing landers and surface mobility systems to explore various regions of the moon, equatorial, north hemisphere, and some of those permanently shadowed craters. We have evidence from orbit that there is water frozen into those craters. The next step is the in situ evidence, going down and scooping it up and analyzing it and say, yep, the water's here. And that's what some of these landers are going to do. Getting humans to the moon, NASA will be using the Orion Crew Module and Service Module you see on the left there, and the Space Launch System. We will also be working with SpaceX Corporation. SpaceX stands for Space Exploration Technologies, Elon Musk Corporation, which has been flying the Falcon 9 now. It just had its 300th mission. I remember when Elon Musk announced that they were going to do the Falcon 9. That was in 2006. So from 2006 to now, 300 successful missions. We have the Falcon Heavy, and then we have Starship and Super Heavy. 33 engines on the first stage of that vehicle. They've had 2 test flights of it so far. First one didn't go too well. They corrected a lot of problems on the second flight, but they still had some issues. They're getting ready for their third flight next month. And my ride's here. The Space Launch System right now is a Block 1 configuration. We'll be going to a Block 2 configuration where the upper stage will be replaced with a much larger stage, much more thrust, much more capability to send cargo to the moon, including human landers. Right now, with the Space Launch System in Orion we cannot send astronauts to the lunar surface. Right now, there is no country, no company on this planet that can send humans to the lunar surface. So Artemis 1 was the first test flight. Artemis 2 will be the first crewed flight. Artemis 3 will be the first landing mission. Because of funding issues with the federal government affecting NASA, Artemis 2 mission will happen at the earliest in 2025. The Artemis 3 mission in 2028 or 2029. The Gateway module will probably see its launch sometime in 2026 or 2027 with the power and propulsion element, which is just what it says, provide power and propulsion, and the first habitable crew module. They will launch in one configuration.
Gateway and orbiter?
Gateway will be in a very unique orbit around the moon. It's called a near rectilinear halo orbit. Fun name. I call it gravity surfing because it's not really an orbit. If you look at the gravitational pull of the Earth and the moon and the sun, you can plot where all of those balance each other. And it's this rounded, cornered, weirdly shaped rectangle. It's not really an orbit. So what Gateway will do is ride that gravitational ridge. And the reason it will do that is because it takes a lot less fuel. Putting something in orbit around the moon takes a lot of fuel. The reason being, like the Earth, the moon is lumpy. It has areas where mass is very highly concentrated, except the moon's a lot worse than the Earth. So those mass concentrations tend to pull the orbit down. It takes a lot of fuel to work against those. This near rectilinear halo orbit is thousands of miles above the moon. It's very easy to control that orbit. So for long-term maintenance, it's a much better place to put a way station.
Is it going to be fixed in that area, or
Yes.
is it going to be moving back and forth in that area?
No, it's an orbit. It'll be moving around the moon, between the moon and the Earth. It'll vary anywhere from 3,000 miles above the moon to about 18,000 miles above the moon. Human landing systems. SpaceX's Starship will have a version that will be used as a lunar lander, and so we don't put all our eggs in one basket. Blue Origin has put a team together that you see here. They are also developing a human-rated lunar lander. They are targeting a demonstration mission of that sometime in 2029 or 2030. My guess it'll probably be more in the early 2030s.
Who does Blue Origin? Is that the name of the company?
That's the name of the company. That's Jeff Bezos' company from Amazon.
Okay.
They've been doing the New Shepard suborbital missions. Their next launch vehicle is called New Glenn. It's a very large vehicle. They have the first test one at Launch Complex 36 at Cape Canaveral right now. They're looking at their first launch later this year.
Does Blue Origin and SpaceX complement each other? They compete?
Like oil and vinegar, yeah.
Okay.
That's like,
That's what
you
they
don't see
have to
SpaceX in this partnership here.
All right. But they're different missions.
They're competitors.
They're competitors.
They're competitors.
All right.
This is Starship and Super Heavy from the first launch on the pad out near Brownsville, Texas. As I said, their third attempt will be is planned for next month. So keep watching for it. It's going to be very exciting. This ungainly looking beast here is called the Super Guppy
Like a
for obvious reasons. As a matter of fact, the European version of that, you said it looks like a whale. The European version of this is called a beluga. So, yeah.
Right.
But this aircraft goes back to the late 1950s, early 1960s. This aircraft carried the third stage of the Saturn V to the Kennedy Space Center. This is the Super Guppy at Lamb Field down in Mansfield, Ohio, bringing the Orion crew module and service module for testing at our facility near Sandusky, the Armstrong Test Facility, that you see in the bottom right there. That dome you see in the bottom right is called the Space Environments Complex. It houses the largest thermal vacuum chamber in the world. It is 122 feet tall, 100 feet in diameter. It can pump down to the vacuum of space in about 8 hours. It is an all-aluminum chamber that is surrounded by a concrete dome. There are aluminum doors that lead in and out of the chamber and concrete doors. Each of those doors weighs about 1 million pounds. There are railroad tracks that proceed from the high bay through that facility out to the other high bay. That's how cargo is moved back and forth in the building.
Could it withstand a nuclear blast?
Not much is going to withstand a nuclear blast. However, the reason that building is built the way it is because in the 60s, NASA was working on nuclear thermal propulsion called NERVA. And this facility was built to test spacecraft using the NERVA system. Aluminum has a low nuclear cross-section in the event of a radioactive accident. So there was never any nuclear systems tested there, but the system has been repurposed. Most of you have probably already had a tour of this vacuum chamber already. You just don't know it. How many of you saw the first Avengers movie? Remember that movie opening, the secret dark energy facility?
Oh, yeah.
That was it. That's where it was filmed.
Cool.
That was filmed in the thermal vacuum chamber. They brought in all their supercomputers to do everything. They used literally 1 million watts of power to power those systems. But it was in the vacuum chamber was that dark energy facility. The staircase that you see them going down underground is actually a service staircase that goes from the top of the vacuum chamber down. So that's where it was filmed.
The Avengers.
But this is the Orion crew and service module from Artemis 1 in that chamber for testing. The picture on the left is in the high bay. On the right is inside the vacuum chamber. The cage around it has infrared lamps so we can test it in the hot temperatures in the sun. Those dark areas are cold walls that will flow liquid nitrogen so we can test the cold temperatures. So you can qualify the spacecraft for the hot and cold it's going to see in space. In addition to that, we also have the largest, most powerful mechanical vibration facility there. It is a vibration table that can handle a test article weighing 75,000 pounds, 75 feet tall. And rockets, when they take off, vibrate like crazy. Well, you got to make sure your spacecraft's not going to shake apart. So you test it. It can mimic the environments of any launch vehicle in the world. As a matter of fact, it can do high frequencies to the point where they first tested it, they couldn't tell whether it was working or not because they couldn't see any vibration. So one of the techs went out to his car, and he had an old hood ornament from the 50s. It was one of these, kind of like the bobbleheads, it was a hula dancer. So they put it on the table, and they knew it was working because they could see the skirt moving. High tech, aren't we?
High
Yes. Also, rockets are very noisy. If you were to stand next to a 747 with its engines running at full throttle and put your ear on the engine, a rocket's louder. The system can do a reverberant acoustic testing at 163 decibels of sound. No one can actually be in the building at the time when the test is happening. But all this testing is what's routinely done to qualify a spacecraft for flight. This is the only facility in the world where a spacecraft can be brought in. All of the testing you need to do to fly it in space can be done without ever leaving the building. You pack it up, you ship it to the launch site. Only place in the world where this can be done is Sandusky, Ohio.
Is anybody else, any other countries using that facility, or is it just us?
Every launch vehicle payload fairing in the world has been tested there. SpaceX has tested their spacecraft here. Northrop Grumman. Dream Chaser is out there right now, finishing its qualification testing. And as I said, this is the crew module, service module from the first Artemis mission. That crew module is back out there now for final testing for certification to carry humans.
So what's the hourly rate?
You got to check?
Are they transported by truck over highways?
Most of them are flown into land field and then trucked up. Yeah, usually in the middle of the night,
Yeah.
moving electrical lines, telephone poles that you need to, avoiding bridges, all of that.
No, it didn't.
Tax dollars at work.
That's right. That's right. And of course, this is the space launch system for the first Artemis mission on the launch pad. This was the trajectory it flew. It did a little gravity assist around the moon to throw it further out into space. Then another gravity assist around the moon so it could come back to Earth. This, of course, was without a crew. Did have a few problems with the heat shield, one of the parachutes. There were some issues with the life support system as well, but those have pretty much been ironed out. So this next series of testing that's actually being done will look at the fixes for a lot of those. And these are photographs from that mission, the cameras that were on board the spacecraft, looking at the moon and looking at the Earth and the moon from where did that furthest point out into space. It's the furthest any human-rated spacecraft has yet gone.
Fantastic. Fantastic.
Artemis 2 coming up. This is the crew of Artemis. This is the crew of Artemis 2. Reed Wiseman will be the commander. He served as a flight engineer aboard the International Space Station for 165 days. They conducted a lot of research into human physiology, physical science, earth science, astrophysics. His flight also included about 13 hours outside during EVA, and he has also served as chief of the astronaut office at the Johnson Space Center.
So is that guy right on a central casting or what? Even his name.
Yeah. Victor Glover will be the pilot for the mission. Like most of these candidates, he became astronauts in 2013. He was the second in command on the Crew 1 SpaceX Dragon, which was the second time that the Resilience Crew Dragon flew. He also served as a flight engineer on the space station himself for Expedition 64. Christina Koch, also from the class of 2013, was a flight engineer on ISS on 3 missions. She set a record for the longest single space flight by a woman of 328 days, and also participated in the first all-female spacewalks from space station. And rounding out the Artemis crew is Jeremy Hansen, who's an astronaut in the Canadian Space Agency. He has not flown in space. He's been a military pilot. He's done underwater research where they actually train astronauts for long missions by going into a test facility called NEMO, which is off the coast of the Atlantic Ocean. And they will literally spend months underwater in those confined environments doing underwater research like you would do in EVA. So it's training for those long missions. Now, Artemis 2 will not land on the moon. It will not go into lunar orbit because the Block 1 space launch system does not have the capability to even put the spacecraft into lunar orbit. They will go into a high trajectory, looping around the moon, going far out in space, and then coming back to Earth. So this mission, which will be the first time we've sent humans to the vicinity of the moon since 1972, is still not as ambitious as what the crew of Apollo 8 did in 1968, because they went into lunar orbit and spent several days in lunar orbit before coming back home to Earth. Since I'm an engineer, I need to have numbers. So here, this is the rack and stack that I think we were talking about earlier. This shows the SLS Block 1, Block 2 cargo against the Saturn V and Starship. I also include the N1 there. The N1 was the Soviet Union's answer to the Saturn V, what they were going to use to send humans to the moon. They launched it 3 times and never worked. So they eventually gave up on the idea. But getting down to some of the real nitty-gritty numbers, SLS Block 1 is about 212 feet tall. Saturn V was 363 feet tall. Starship and Super Heavy is 394 feet tall. The Saturn V, first stage, its 5 F1 engines, by the time of Apollo 17, was generating almost 8 million pounds of thrust at liftoff. SLS Block 1 is almost 9 million pounds. That's thanks to the 2 very large solid boosters that are strapped to the side. Starship Super Heavy at liftoff generates 17 million pounds of thrust from 33 Raptor engines. And the reason for that is the Starship is completely reusable, and that's what it puts in low Earth orbit. The Saturn V put the Apollo command and service modules, the lunar module, the 3rd stage of Saturn V into low Earth orbit. That was about 290,000 pounds. The Block 1 will put the Orion crew and service modules plus the cryogenic upper stage it carries for about 209,000 pounds. But Starship, putting that entire Starship into low Earth orbit, is over 3 million pounds. This is the gateway station. This is what it will look like in its final configuration, with modules from the United States, from Europe as well. The core of it will be the power and propulsion element, which does exactly what it says. It will provide power and propulsion for the system. Propulsion will come from the largest electric thrusters ever put into space. 4 of them, each consuming 40,000 watts of electrical energy generated from the solar arrays. They're called Hall effect thrusters. Those engines were designed and developed right here at the Glenn Research Center in Cleveland. It will carry the Habitation and Logistics Outpost, or HALO, atop of it during this mission. I shouldn't say atop of it. HALO will carry the power and propulsion element atop of it on the launch vehicle for the first mission. And that's probably going to be sometime in 2025 or 2026. And then the other modules will go up on launches as we continue to build it in that HALO orbit around the moon, just like we did the International Space Station in low orbit around the Earth. Now, all these things I've talked about, and you can find out about them. The Moon to Mars architecture is on the NASA website. The link is here. I'll be providing Ron all of these charts so you can, however much he wants to charge you for them will be up to him. I had a few copies on the back of the summary presentation for this architecture study. You can download the full version. It's almost 500 pages. It gives you the gory details of everything we plan on doing on the moon, why we're doing it, how we're doing it, and what it means to get us to Mars. And the why we do it is what's important. Remember I said that NASA's direction is that everything we do is for the benefit of all of us. And where we are now is, as I said when I started, we're at the beginning of what used to be science fiction, but it's not anymore. This planet we live on is not an infinite resource of anything. we're running out of fossil fuels. We have less than a century of fossil fuels left. We need to look at alternatives to that. Wind, solar, wave energy, nuclear fission systems. We've been working on nuclear fission. I'll get this right yet. Nuclear fusion systems for the last 50 years. And we're finally getting to the point where we're making breakthroughs where we can have sustained reactions. We're still not getting as much energy out as we put into them, but we're getting there. But no matter how much we conserve the resources here on this planet, we will run out. No matter how much we recycle. Every time metal is recycled, it weakens its molecular structure. There will come a time where you can't recycle metals anymore. They will be useless to us.
Takes energy too.
Yes, it does. Yes, it does. The other reason is the Earth is a target. We are at the mercy of the leftovers of when the solar system formed. We look at the moon, we look at the impact craters there. We look at Mercury, we see it littered with impact craters. We see them all through the solar system. There's just as many impact craters on the Earth, but we have an atmosphere that erodes those craters. And we have vegetation, and we have human beings that have built things up so we don't notice them as much. In 2013, a relatively small asteroid fragment exploded over Chelyabinsk, Russia. It was estimated to be about the size of a house, weighed about 60 tons, entered the atmosphere at about 40,000 miles an hour, was not detected before it entered the atmosphere, and it exploded about 1,200 miles up. But that explosion was an equivalent force greater than that released from the atomic warheads that were exploded by the United States over Hiroshima and Nagasaki. It damaged buildings, it injured people from collateral damage over a 2,000 square mile area in Russia. So imagine if that exploded over New York City, Washington, D.C., London, Tokyo, a major population center. Just the collateral damage alone. It doesn't have to hit the planet, but just the collateral damage alone. And it is not a matter of if an asteroid fragment is going to hit the Earth. It is a matter of when. It will happen. We're fortunate in that just over 70% of this planet is water. However, that can create a tsunami, which can destroy coastal areas. So, it sounds like science fiction, but one of the prime goals is to begin the process of getting humanity off this planet. I have a button on my coat that says, "The meek shall inherit the earth. The rest of us will go to the stars." But it's not as though we're going to look at abandoning the earth. And when you look at everything that NASA has done over the years, a lot of things we do have become inherent in what we do every day. We don't even think about them. We turn on the news at 6 o'clock, and we look at the weather reports, and we look at the satellite imagery. They tell us which way a hurricane is moving, which way there might be tornadoes developing, and we can evacuate people. We can batten down the hatches and preserve property as much as possible. Without satellites, we wouldn't be able to do that. This started with the Artemis Program that NASA did in the early 1960s. It was one of the first applications of satellites. Take away NASA, take that ability away. How many people in here have satellite television at home? Dish Network or Direct TV? Do you have cable TV?
Yeah.
Even if you have cable TV, it's still satellite TV. They're just beaming it down and sending it out over wires. The reason you can get by with a 12-inch dish on your house instead of a 12-foot antenna in your backyard, which is the way it used to be, was thanks to a device called a traveling wave tube assembly. It was invented and developed by Dr. Henry Cosmo at the center here in Cleveland. It was designed to amplify those signals from a spacecraft so you could have a very small antenna on the ground. That's the reason why DirecTV, that's the reason why all satellite providers exist today, is because of that work. And most people don't know it, but in 1988, the center received an Emmy Award because of the development of that hardware. Take away what NASA did, take that all away. Many people have implantable medical devices, pumps, insulin, even cardiovascular devices, ventricular assist devices because they have weak hearts. One of the reasons why those systems are successful is because they use a software code that was developed to analyze the flow of propellants through rocket engines. That propellant flow has to be what is referred to as perfectly laminar, absolutely smooth, no gases, no bubbles, no voids, nothing. Just like the blood in our bodies. That code was adapted for the use of these implantable devices. So if you take away NASA's impetus for developing that code, you can take those things away. Has anyone here ever had a CAT scan or an MRI? Yeah, silly question, right? When we build and test a spacecraft, we want to make sure there's no latent damage that we can't see. So we had to develop non-destructive evaluation methods. That was the first ultrasound. That led to its use in medical. Then we needed to do something better because of different materials. That led toward CAT scans and then the development of MRIs. That started because of the aerospace industry. Imagine taking that away from the medical field today. But if NASA didn't work on that, it wouldn't exist. Anybody here have a cordless tool of any kind? Silly question. You know, cordless tools existed before NASA. They were big, they were bulky, they didn't last long, and nobody wanted them. The Apollo program needed a high-powered drill to get core samples from the lunar surface. They went to Black & Decker, and Black & Decker came up with that drill. And that spawned the entire cordless tool industry that we now have today. Take away NASA, go back to your corded tools, folks. We all get insurance breaks in our homes because we have CO detectors and smoke detectors. Those were developed for the Skylab program because in microgravity, low pressure environments in space, things can give off fumes that can be toxic to astronauts. It wouldn't happen down here under higher pressure. So these first types of sensors were in Skylab. They were needed for that type of work. Take that away, take away those detectors. Laptop computers. Our cell phones, which are computers. There's 10,000 times more power, computing power in this cell phone than in the computer that landed the Apollo astronauts on the moon. That computer was a 12-bit computer. Not bytes, not kilobytes, not megabytes, 12-bit computer. The impetus to make computers small was the space program. Computers were the size of this room. You know, there was a reason why a problem with the computer was called a bug, because those original computers had problems because cockroaches got in them. Literally, the bugs got in the computers. But the impetus for making these small computers came from NASA. So without NASA, take away those computers, take away your cell phones. I don't know about you, but I got here pulling up Google Maps. Global Positioning System satellites, data comes through the cell phone towers. Take away those satellites, take that away. You go to any store, when you check out, you're scanning those UPC codes across the little laser scanner. Those UPC codes were developed for the International Space Station. We had to inventory what was going up there and what was there because we have to keep track of it from a mass standpoint. You got to know everything that's there. That's where it was invented. That's going to be replaced soon by RFID chips, which you'll have your grocery cart absolutely filled. You'll walk it through an archway, it will scan it, ring it all up, and you go. You don't have to take everything out and put it back in. If you have Ohio Easy Pass, anybody have it? You've got an RFID chip. Ever wonder why you don't have to replace the battery in those? Because there isn't one. Doesn't need it. When you go through the toll gates, there's a radio signal that's transmitted to that Ohio Easy Pass. That radio signal charges a capacitor. That capacitor discharges and sends a signal back that tells the system who you are and charges your credit card. It's an RFID chip. All that came because NASA needed them. Take NASA away, take that away. The gentleman you see here on the bottom right of this picture, on the bottom right, is Dr. Rafat Ansari. He worked on experiments on the space shuttle on the International Space Station looking at protein crystal growth. We can grow those crystals much cleaner in space because gravity doesn't deform them. It turns out the crystals he was looking at are the same proteins that are in the vitreous fluid in the human eye. And he realized that an application of what he was doing could be used to detect whether or not you're going to develop cataracts. And he worked with the Cleveland Clinic to develop a diagnostic system that can tell you whether or not you are going to develop cataracts 20 years before they even start to form. So take away that work he was able to do in space, take away that ability. And of course, the first A in NASA is aeronautics. There is not a single system on an aircraft, safety, propellant, engines, that has not been touched by NASA in one way, shape, or form. And now we're extending that to uncrewed aerial systems, UASs, drones, flying cars, which you will be able to see soon, how those are controlled, how you handle the air traffic congestion. That's all part of what NASA does. You remember the movie It's a Wonderful Life? Where Jimmy Stewart's character gets to see what life would have looked like if he never existed? Well, that's what life would look like if NASA never existed. Those things I talked
Before
about.
NASA existed.
Yeah. When you look at NASA's budget is less than half of 1% of the federal discretionary budget. So if you represent that discretionary budget by a dollar bill, NASA's share of that is less than half of a penny every year. If we all got a bill in the mail to support NASA for a year, your bill would be about $75. If you got a bill in the mail to support the rest of the federal government, it would be almost $17,000. Don't send me that bill because I ain't gonna pay it. I'll tell you that right now.
You're paying it.
Yeah, I'm paying my own salary because I'm a taxpayer. So.
Yeah.
But that's the reason what we do. I mean, this is all out there. Everything NASA does is available to the general public because you're paying for it. So when we started this, we talked about exploration of the world. This was a 12th century map of the world. North is actually down on this map because of where it started from. We didn't know much about it until we started exploring. And then in the 15th century, we started knowing a little bit more. You see more detail in Eurasia and Africa. And you start seeing just a little bit of the Americas. It's just we continued moving across the planet. And by the 17th century, it starts looking like the maps we know today. The US map itself, this is 1682. And here it is in the 18th century. Remember, at one time, Ohio was the Wild West, as far as the US is concerned. We are literally standing at a fork in the road. Do we continue as we've been going, or do we take that path less traveled? The path that is literally going to take us off the earth and continue our explorations. If you look at the explorers who went west, they lived off the land. They developed places to live. And eventually, those congregated into the first towns in the west. And analogous to this in the 20th century is McMurdo Station in the Antarctic. It's a bustling city. It has schools. It has shopping. This is on Antarctica. It started from scientific research as an outpost. It's a full-fledged colony. This will then extend to the lunar surface and eventually to Mars as well. These are our next frontiers. This is a map of those southern polar regions I was talking to you about. Shows potential landing sites, particularly around what is called Shackleton Crater, which is in permanent shadow, the edges of which are in that deep twilight I was telling you about. On the right is an image from that crater by a very special camera that was made in the US that was actually carried on a Korean satellite. What looks like light areas are actually areas of perpetual darkness. This can literally create images from single photons of light. And we can have our first actual glimpse into those craters. And this is just a little bit large. You see those bright areas on the rim? Those are potential landing sites. Where you see a really bright area are those areas of perpetual twilight. But the poet laureate Robert Frost put it perfectly. 2 roads diverged in a wood, and I took the one less traveled by, and that has made all the difference. That's where we're standing right now. The gentleman on the right, Konstantin Tsiolkovsky, is considered the father of astronautics. He developed the equation called the Tsiolkovsky equation, or simply the rocket equation, which we use to this day. It's a very simple relationship by how efficient is your engine, what type of propellant do you use, how much propellant do you have, how fast do you need to go, and here's how well it can do it. He published hundreds of papers on space stations, what we would need to do to live in space, the problems we would encounter, how to navigate in space. All of these papers were published before the Wright brothers' flight at Kitty Hawk. What makes it even more impressive is that Konstantin Tsiolkovsky was never educated formally. He was deaf. He was told by everyone that he could never amount to anything, but he knew better. He taught himself, and he far exceeded anything that anyone had ever accomplished for that time frame over 130 years ago. And his work is still laying the groundwork for us today. So we have to ask ourselves the question: what will a 22nd century map of our home look like? We saw those maps from the 12th and the 13th and the 15th and the 17th centuries. So what will our map look like in the 23rd or the 30th or the 50th century? It's up to us to determine that. Our home is going to be wherever we want it to be. And where I'd like it to be, second star to the right and straight on till morning. That's the end of my tirade. Thank you, folks. If anyone has any further questions, I'll be happy to entertain them.
I've got a question.
Yes, sir.
The space shuttle has been retired, of course, and this Orion, I assume that's the one that's going to take place. Is it similar to the space shuttle? I mean, will it be landing, or is it?
No, it's a larger version of Apollo. It will splash down in the ocean, just like Apollo did.
Why did they give up on the space shuttles? It's just, I mean, a reusable thing that lands. I thought it was a very cool idea, but
The space shuttle was our first attempt at a reusable system.
right.
It ended up costing a lot more than anyone had hoped. It was more complex than anyone hoped. It was hoped that this could be cheaper. As it turns out, it's going to cost more than the shuttle. As a matter of fact, NASA can only afford to do at most 2 space launch Artemis missions in a year. We just can't afford to do anymore. I made a bet with people I work with when Orion was first launched in 2004. This is another, I'm a systems engineer, so I got to step back and look at things. From the time the Apollo program, Saturn V, was started in 1958. The first time it sent humans to the moon was 1968. Orion, the space launch system under different names, started in 2004. The first time it may send humans to the moon is 2026. What's wrong with this picture? I made a bet that Orion will never carry humans who will land on the surface of the moon, and I'm still holding to that. The first humans to walk on the moon after Apollo will probably be SpaceX astronauts, a private mission, not NASA.
They have more money on it.
Anyone else?
These rockets that Musk is flying, that land, is that helping with the cost, I assume, right? If they can reuse those things?
Oh yeah, yeah. You don't have to build everything brand new over again. Yeah.
But it's just the main booster is the only one landing, right?
Right now, yeah. Right
Is he-
now.
is
Now
he
Starship, the Super Heavy and Starship will both be reusable. They will both be reusable.
The whole thing? Or
The whole
just-
thing.
Is
The
that
whole
right?
thing. Yeah.
They're gonna bring those things back down and land them?
Mhm.
Ew.
You wanna go for a ride?
Yeah.
Ooh.
I'm looking forward to watching that sucker. Let me tell you.
Oh, yeah.
I always imagine. I tell people. I said every time a Falcon 9 first stage is brought back and lands, I think Elon Musk goes into his office and closes the doors, and he has this secret panel that he opens, and there's this illuminated NASA insignia, and he looks at it and goes. We tried reusable launch vehicles several times. We failed every time. We failed every time.
What did he do that we didn't do?
Persevered. He had the money to do it too.
Do you have
Yeah,
better engineers?
Got a
No.
commercial
No.
interest versus national will.
He had more drive as an individual.
He wasn't a political football. He was able to do what he wanted to do and had the money to do it. NASA has never had that.
Pretty
Still doesn't.
recently, there was a launch vehicle that was landing on one of his barges, and it failed and fell over in the water.
Yeah.
But I told my wife, that's a bummer. But that was the 19th time
That's right.
that thing had landed, or
That's right.
That was the 19th try it failed.
Yeah.
Okay, well,
Yeah,
that's
he's used
pretty
Falcon,
good.
He's used Falcon 9 first stages
Yeah.
now over 20 times.
Yeah.
Well, bring it up to the gas tank, fill it up. You check out the whole system. Obviously, replace what you need to, but that you can tell by how scorched they look. You don't need to paint them again. Why bother?
Rusty rockets.
Yeah. Anyone else? All right. Well, there's still handouts on the back there. Feel free to help those, and thank you very much.
Thank you.